So it runs automatically, and it also automatically opens a browsing window with new file system response. And that's actually pretty bad, because the file browsing window generates thumbnails for all of the files in the root directory for the Linux. To generate the thumbnails, it has to open these files, read the data, and parse them. So if you have an image on your USB disk and you stick it in, it's going to render a thumbnail of the image or a document. And that's pretty dangerous because those files could be untrusted. They could have a malicious code in them. And the really interesting thing is that it does this even when the screensaver is running in lock. That's something that Windows doesn't do. If you have the screensaver running on Windows and you insert a USB, even if you have Autorun and everything configured, it doesn't do anything if the screen's locked. But Linux, on the other hand, will. The screensaver is just a process that runs. So here's an example of just how the thumbnails look like. There are pictures, there's some images, it generates thumbnails for fonts. And the configuration options. These aren't the default options, but you can see over on the left, there's a checkbox on the bottom called Browse Media when Inserted. That's a really bad thing to have checked, so if you're using Ubuntu right now, you should go ahead and uncheck that right now. And another problem is something else you might want to do is disable previews. Over on the right, it has the options for generating previews, which is what they call thumbnails. And yeah, this should not be enabled either. But they are by default. So here's a slide that talks about how Nautilus works. So when a new storage device is connected, the kernel ends up sending a message to udisks, which communicates with dbus and going from the other side. And there are a bunch of other utilities and libraries that are involved, and it took me a pretty long time to figure that out, but I'm sure they already changed it by now because they tend to change the subsystems around in various distributions of Linux every couple of years. It makes it pretty hard to understand. There's a lot of different code that you have to look at to actually figure out what exactly happens when you're mounting a new device. All right, so I can talk about how the thumbnailers work, and this is where I kind of focused my efforts when I was looking for vulnerabilities. So Nautilus generates thumbnails for images, movies, documents, and other file types. The settings are stored in gcomp, which is it's kind of like the Windows registry. A lot of these ideas seem like they came from Windows, and it's a really bad place to get your ideas from if you want to have a secure operating system. So any image icons are generated internally using GDK Pixbuff, which is a library that generates images. It supports a whole lot of different image formats. But you can also have third-party icon handlers. For example, Events Thumbnailer handles document files. There's one called Totem Video Thumbnailer that generates thumbnails for video and audio files. And thumbnails for audio files don't automatically play the sound, but they give you the option of playing the sound. And then Gnome Thumbnail Font, which that handles font files. And whenever you are browsing files and it generates thumbnails, they're cached in your own directory and the .thumbnail/normal directory. So GDK Pixbuff, this relies on a lot of third-party libraries, and some of these libraries have had vulnerabilities before. In fact, they all have. libdng, libdiv, and libjpeg. They've all had vulnerabilities before. There's also some built-in code for handling other formats like BMP and GIF and others. So there's a whole list of the supported file extensions there, and some of those probably aren't used very often, and the code that's used to render them may not be that great. So it could be an interesting place to look for vulnerabilities if you have if you're interested in looking at those libraries. So it could be kind of difficult to exploit bugs in GDK Pixbuff because the thumbnailing happens in the Nautilus process itself. So if the process crashes, the file browsing window just goes away. So if you're trying to defeat a non-executable stack in ASLR by brute forcing addresses, it doesn't really work because as soon as there's one crash, the Nautilus crashes and it comes back up, but it's not browsing that same file anymore, so you have to click it again. it's probably not very easy to get a successfully working exploit against the GDK fix bug. So there's also, besides the internal image thumbnails, there are also external image thumbnails. These are configured through the GComp system, like I said before, and there's also a user interface for configuring that called GComp. And you can see here that these work by kind of the MIME type. So XDVI is configured to use the command events thumbnailer with those three arguments. It's the size, the input file, and the output file. And you can see it's enabled. You can also disable all of these. You can either enable them or disable them on a case-by-case basis, or disable them all. I like to have them all disabled. So more about external thumbnailers. Like I said, they're configured with GComp, and there's a command line you can run, gcomp tool-r, and that path, and it will list all of the thumbnailers that are configured to run in your system. And like I said, there's an example, total video thumbnailer -s. -s is there, %s is the size, %u is the file, %o is the output file. And Nautilus looks up the thumbnailer application for each file based on the MIME type. So if you want to trace back, if I go back to this slide, if you want to trace, if you want to figure out what file types x-dvi are, you have to look somewhere else. You have to look in the MIME type database, and which is stored in a different spot. I don't have the information on that. First, I took a look at events thumbnailer. It's part of known events, the document reader. It supports a lot of different file types: PDF, HW, CD7, which is a comic book format, which is basically just a zip file with images in it, EPS. So when events thumbnailer is called to generate a thumbnail for a document, it renders the first page of the document, uses the icon. So it opens up the document, figures out what's on the first page, renders it based on the font and everything else, and it shows a little picture of the document. So it makes it easy to, if you know what the first page of your document looks like, it makes it easier to see. It relies on some third-party libraries for some formats and internal code for others. And luckily for most people, that's protected with PIE, which is Position Independent Executable, one of the exploit mitigations present in Linux, and ASLR, which I'll get into a little bit later. Totem Video Thumbnailer supports a lot of different formats, and like before, a lot of these formats are probably very old, and the code to render them might not be that good. For example, the ANN 1 through 9 format is from Amiga computers, which nobody really uses anymore except people that are really into the hobby. So I don't know why it should automatically render movies using that format. And some of these formats I don't even know what they are, and it's actually pretty difficult to track down the code for each of these formats. You get the code for, you have to find the code for Totem, the video player. Once you have that, it uses a lot of external plugins, and then you have to track down those plugins, and it's really not easy to figure all that stuff out. So good luck with that. But the interesting thing is that Totem Video Thumbnailer is not protected by PIE or ASLR. So that makes it a little bit easier to get exploits running. If you can find a bug that can be exploited through Totem Video Thumbnailer. And then there is known thumbnail font, the third one that's configured by default. It provides thumbnails for TTF files, DPC, various other ones. It uses the FreeType library, and there have been vulnerabilities in FreeType reported in the past. Vulnerabilities in FreeType are good because they can also be exploited by a web browser. That's not what I'm talking about today. And known thumbnail font is again not protected by PIE or ASLR. So if you get an exploit running with known thumbnail font, you don't have to worry about some of the mitigations that are in place for the other ones. So Linux does have some mitigations because of a lot of hard work that people put into them. So there's a lot of security features. NX, non-executable memory. This is a feature of the CPU to make sure that data that shouldn't be executable is not executable. For example, it protects the stack and the heap, just to make sure that anything that is counted as data isn't executed as code. Then there is ASLR, which is address space layout randomization, which is on basically everything. All the libraries that you load. So there aren't really any static addresses you can rely on if you're trying to get an exploit working. And then there is PIE, which is Position Independent Executable, which is basically just ASLR for Linux ELF format files. And then there is AppArmor, which is a kind of a firewall for system calls. And what that does is, if you have an application that's protected with AppArmor, there is a policy in place, and that policy specifies which files what files and system calls that the application is allowed to access. And for example, most AppArmor profiles will prevent a protected application from launching a new process. And that helps a lot because it's hard to get an effective exploit working without being able to launch another process. So anytime that you're trying to get an exploit working, you have to get past AppArmor if the application is protected with that. And really, there aren't very many applications that are protected with AppArmor by default in Ubuntu. It just happens that Events, the document reader, is one of them. That was a real pain for me. So NX itself isn't very effective by itself. You can use return to libc or return-oriented programming exploits to get around that. That's where ASLR comes in. ASLR mitigates rot because for return-oriented programming to work effectively, you need to know the address of the instructions, and if the libraries are a different address every time, then you won't know where they are. So it makes it very difficult to build a ROP payload with ASLR. And AppArmor itself can be pretty tough to defeat, but there are some weaknesses. For example, I already talked a little bit about this, but the protection is defined per application. So if you find you can find holes in some of the rules, and I did find some weaknesses in some of the rules. And there are also some things that AppArmor can't protect against, and I'll talk about those in a couple more slides. So how do you get around ASLR? Well, the one way to do that is to brute force it. And that's really awesome because the external thumbnailers are launched as a separate process for each file. And if that process crashes, there's no error checking for it, so the other files will continue to be thumbnailed. So if you're trying to brute, there's around 3,000 or so different addresses that Linux will be able to load a library at in default configuration on a 32-bit system. So you can have about 3,000 different files, and there's a pretty good chance that one of those is going to, one of those exploits can be successful just by guessing the address of the library and hoping that you hit it. But like I said, if you're looking at something with GDK pick stuff, then that's not in a separate process. That process crashes. So that's why I was mentioning that you could brute force ASLR with the external thumbnailers. Yeah, so there's around 3,000 addresses that can be used. So you can just create 3,000 different files with different addresses for libc, or even all with the same libc because it'll be loaded at a different address every time, and you have a pretty good chance of having your exploit succeed. But you don't really need 3,000 addresses in most cases on the default version of Linux. So I was doing some research, and I wrote a script to figure out where the base address of libc was, and about 40,000 runs of even thumbnail. And it turns out that the vast majority were up here in the 00FF range. So I figured out that I only need about 300 or 400 files to successfully brute force ASLR on Linux. And I don't know if they're planning on fixing this or not, but that's something that I haven't looked into why it looks like this. I haven't spent much time analyzing the algorithm they use to calculate the base address of a library, but it is pretty interesting. It's something that needs to be looked at.
What kernel version?
Whatever was in the latest Ubuntu 10.10,
Okay.
so 2.6 something.
There was a pretty bad weakness in the